so there's real sophisticated ways of getting water clean, and in the developed world, uh, everybody has these types of municipal water treatment facilities. However, that's not the case all over the world, and you can see by this world map, the green, the areas mostly in the northern hemisphere, the dark green, and Australia, have advanced societies. They're not, they're first world nations, and keeping drinking water safe and access to the population is not a problem. Over 90% of the people have access to clean drinking water, and you can see how things change. Just look at the continent of Africa. It's really sad. In parts of Asia and South America, where only 75% to 90 or 60 to 75%, and there's extreme cases in sub-Saharan Africa where possibly less than half the population has access to clean drinking water. So this is a major problem that inhibits the well-being of these peoples in these areas. Is if you're sick because you don't have clean drinking water, you can't have a water source to keep your livestock with water and your crops with water and your people not sick, then it really inhibits the progress of those countries. So that's a bit of an issue. Another problem is, or another way, or I should say another problem is if there is no groundwater to clean up. And a lot of these places is just very arid and dry, and so they don't have water. But if you have enough money, as for example in Australia, you can, you're surrounded by water, and most of the population lives, around the edge of this continent. You can clean up salt water. It's just more expensive, but if you've got the money and you have another choice, that's what you do. And there's two main ways to clean up salt water that's different than cleaning up groundwater, fresh water. One of them is, of course, you have to go through all of the treatment that you would for surface water to get the big stuff out and the dirt out and stuff. And then beyond that, you have to separate the salt from the water. And one way is this process called distillation. And this is just an example of a little distillation setup that you'd have on your bench top. But you could imagine industrial size distillation apparatus would be set up if you were trying to clean up enough salt water for your whole city. And in this case, you're just the salt water is heated and it boils. And the salt, when it boils, it's boiling, it's the water going from the liquid to the gas phase. The salt is not the boiling point for salt, so the salt does not boil, it stays behind. And so what happens is the water is separated from the salt water, and it goes up, up the tube, and then it's channeled down over this way, and then this has cold water flowing around the outside of it. This is called the condenser. Water in, water out. It's a cooling water that's on the outside of this tube. This is like a double tube with an inner layer and an outer layer. The outer layer has cold water going around it, and then the water vapor that boiled up here then will condense, collect as liquid, and then drip down into a collection device. And so this is called distilled water. That's why distilled water is not an electrolyte, because in this way you have removed the salts. Really what you've done is remove the water from the salts, and so it's a way to get pure water. Okay, so you imagine it's more expensive because you have to clean up the water. Like a regular treatment plant, you got to get out, the big stuff and the dirt and all that kind of, and the organics. Then there's one more step, which is very energy expensive, and so getting water purified this way is expensive. Another technique that's used is reverse osmosis, and this way. Well, first of all, let me tell you what osmosis is. If you can't remember, osmosis is when a solvent moves across a semi-permeable membrane from a region of low solute concentration to a region of high solute concentration. That's regular osmosis. Okay, and so it's the solvent moving across the membrane from a region of low solute concentration to a region of high solute concentration. So what you'd have here, say, is an apparatus with this is a semi-permeable. Semi-permeable means some things can cross and some things can't. Membrane. And so let's say there's water on this side, and then there's salt. This is salt water on this side. What happens is actually the water will move from the low solute to the high solute side, and what the water is trying to do is dilute the salt, because the salt can't move across the membrane, but the water can. So water would move in this direction to try to dilute, to have the higher salt concentration move to a lower salt concentration to equalize across the semi-permeable membrane. So reverse osmosis is where you put and the osmotic pressure then is there'll be a certain point where the water no longer can move in this direction, and it's moving, and that's when the pressure builds up so much on this side. The water moving to the higher solute concentration, trying to dilute it, can no longer move, and there's actually movement in the back and forth with the solid, would be back and forth in both directions at the same rate, and then this concentration wouldn't change anymore over here. Okay, that's that concept of osmotic pressure. And so what you do here is the salt water is coming in on this side, and so this is the salt water, and this is the semi-permeable membrane. Well, the regular water, the clean water, really wants to move in this direction across this membrane to try to dilute this salt water, but instead high pressure is added to this side, forcing the the solvent water in this direction. Okay, the water wants to go in that direction, but if you have high enough pressure, it overcomes the osmotic pressure, and you push it across the semi-permeable membrane in a direction that it doesn't really want to go. But what it does is it separates the salt from the water. Okay, so you're taking advantage of the semi-permeable membrane, which only allows the solvent water and not the solute salts to pass, and then you force the water in a direction that it wouldn't normally go. That's why it's called reverse osmosis instead of regular osmosis. It's pushing it in the opposite direction. Anyway, it's a real popular way to purify water. And salt water. Sometimes, like boats that are seaworthy will have little reverse osmosis water purifiers used to purify the salt water on the boat. Okay, all right. So water is a solvent. It's a solvent because it's a major component in the mixture. So the mixture being water with all the other stuff in it. So care has to be taken to remove the contaminants from water so that we can have clean water. So clean water is necessary for prosperity. It's necessary for health and wealth and economic stability for any kind of civilization. And so you can see in the world the advanced economies have this down, no problem. Everybody takes it for granted that you're going to have plenty of clean water, but the areas where there's not such economic stability or political stability, they still have problems with just getting clean water.